People often drink alcohol to minimize the intensity of negative emotions that they experience and to promote relaxation. Alcohol brings about these effects by binding to GABA receptors on the postsynaptic neuron. Alcohol is shown in orange, binding to the blue GABA receptors. When it does that, it causes GABA, which is shown in pink, to bind more tightly to its receptor. It also causes the chloride channels, which are the GABA receptors, to open wider and to stay open for a longer period of time. As a result, more chloride enters the postsynaptic neuron via the GABA receptors, and this continues for a longer period of time. Since the chloride brings in negative charges into the postsynaptic neuron, it causes a prolonged hyperpolarization. We also have a prolonged IPSP, and so the effect of alcohol is much more pronounced on the limbic system than GABA alone. It is widely known that marijuana elevates the mood and promotes relaxation. So let's take a look at how marijuana acts on the brain and on the synapse in particular. So here we have a synapse. The action potential has just arrived at the synaptic knob. It opens voltage gated calcium channels, which are in the synaptic knob. Calcium rushes in and causes exocytosis of the synaptic vesicles. These synaptic vesicles are carrying a neurotransmitter called glutamate. Glutamate is the most important excitatory neurotransmitter. So, glutamate binds to its receptors on the postsynaptic neuron and opens ligand gated sodium channels. Sodium rushes in and causes depolarization of the postsynaptic neuron. This is an EPSP. Glutamate tends to be highly excitatory to the point of being toxic. In order to counter the effect of glutamate, postsynaptic neurons often produce another neurotransmitter called anandamide, that is shown in blue. The word ananda in Sanskrit means joy or bliss. So anandamide leaves the postsynaptic neuron, goes to the presynaptic neuron, and binds to receptors called cannabinoid receptors, or CB1 receptor for short. That's shown in green. So the anandamide binds to that, and as a result, it causes the calcium channels to be blocked. So when the calcium channels are blocked, when the action potential arrives at the synaptic knob, the calcium channels are no longer functional as a result of this binding of anandamide. So no glutamate is released, no more glutamate is released into the synaptic cleft, and so the excitation of the postsynaptic neuron reduces quite a bit. So this is actually beneficial because we don't want the postsynaptic neurons to be in a very high level of excitation. This results in a roundabout way, results in elevating the mood and increasing relaxation. So what happens when someone uses marijuana? Marijuana contains a compound called tetrahydrocannabinol, which is THC for short. THC binds to CB1 receptors, but its effect is much more potent than the natural binding of anandamide, and so it lifts the mood much more and causes a profound level of relaxation. While the occasional use of marijuana can improve mood and promote relaxation, chronic use of marijuana can have adverse effects on memory and cognition. This is because majority of the CB1 receptors are present in the learning part of the brain, which is called the hippocampus. And when marijuana is abused on a regular basis, the THC binds to these receptors and lowers the level of cognition. This makes sense because glutamate, the neurotransmitter glutamate, has a direct role to play in long term memory and learning. And all of this is affected by the use of THC on a regular basis.